Okay, so in vectors question, some of the long questions will end up asking you to find ratios of area. So that's where a lot of students actually find that type of question difficult. So basically, there are three methods of finding such area. Okay, but I will not be going through three methods. I will go through the basic two methods. Okay, I will skip the third method. Okay, unless you are interested in the third method, or else right, I'll stick to the basic idea of method one and method two. So when you're finding ratios of area, the main method will be similar triangle. So using similar triangles, that will be one of the more basic method. So we'll try looking out for similar triangle. So when two triangles are similar, if you still remember, their ratio area is the length ratio squared. So if they are similar, you just take the length ratio and you square it. So that's one of the easier one. The common height is the one that a lot of students couldn't. So sometimes when the triangle is not similar, you got to look out for common height. So what do I mean by look out for common height? So let me draw the triangle that are common height. So this is A1 and then this is A2. So obviously these two triangles are not similar. They don't share any angle. They got no same angle. So if you still remember, to qualify for similar triangle, actually all the angles are supposed to be the same. So it's your AA proving ideal to qualify for similar triangle. So in this two questions, in A1 and A2 are not similar. So A1 and A2 are not similar. So this is the first thing you must tell first. So why is it not similar? They don't share any common angle. They don't share any same angle as well. So in fact, right, A1 and A2 share a common height. So where is the common height? So between the two triangles, the connecting point between the two triangles, you can drop down a perpendicular height. So this is the height that is applicable for A1. Because if I use this height, A1 will be half times height times B1. And this will also be the height that I can use for A2. Half times height B2. So if I end up doing a ratio, my half and H will cancel. So the ratio of area, the area ratio is reduced to base ratio. So common height has the ability to cancel the height. So that's why you are left with base ratio. So area ratio is the same as base ratio when you are dealing with triangles of common height. So if you are dealing with similar triangle, then it will be length ratio square. You got to take the length ratio and you square. Square when it's similar triangle. So a lot of people get confused. So when do I square it? You square when the two triangles are similar. If it's common height, you will not be squaring the ratio. It will just be reduced. The area ratio will be reduced to a base ratio. Okay, so a common height is something where you don't need a lot of working. You can just visualize it. Okay, so I'm going to show you some sample of this ratio first without any vectors. So for example here, let's take a look. Okay, with all the information given, ADE and DBF. ADE and DBF. So it's quite obvious to tell that these two triangles are similar because they are parallel lines. They are parallel lines, so we can actually tell that they are similar. So you don't need to prove the similar. You just need to be able to tell that they are similar. And you take any one of the length. So I'm going to take AD. And I'm going to take DB. I'm going to take the respective length. Take the length ratio and you do a square. So if you can tell that they are similar, take any of the length ratio and then you can square them. Okay, the next one is the one that is a bit more difficult. That is also DBF. Okay, with EFC. So EFC is here. So these two triangles, they share a common height. So if you take a look, they share a common height. So they are in between a pair of parallel lines. So the height here is the same as the height here. So they got the same height. So they got the same height. So if you want to observe, triangle DBF will be half times height times BF. I don't know my BF. Okay. And then for triangle EFC, you'll be half times height times FD. So I got two unknown lengths. So now I got some trouble. I know that I need the base BF. I also need FD. Okay, but I don't have the length yet. So okay, you got to take a careful look. So what I can do is, I'm going to let this part be X. If this is X, this part will be 24 minus X. So I'm going to let FD be X. Then BF will be 24 minus X. So I need you to realize that this is also a X. Because in a way, this is a parallelogram. So some students never realize that this is a parallelogram, so they didn't know that there is an X. So because of this, right, so DE is also an X. And if I use the previous triangle, if I use the previous similar triangle, ADE and DBF, so if I use that, the previous pair of similar triangle, if I compare the base ratio, it will be the same as the side ratio. So you go for your calculation, you will get X equal to, I think it's 8. So that will be an 8. And then this part will be a 24 minus 8. So with all these, I can find the ratio. So DBF over triangle EFD. So half times height times BF. Half times height times FD. Cancel. And BF is 24 minus X. Which is 24 minus 8 over 8. So you will get a value 2. So the ratio is 2:1. So this question is a bit difficult because you need to detect that they are common height. After you detect that they are common height, you still need to be finding the respective base using another pair of similar triangle. Okay. Now, the next one is an O-level question that deals with similar triangle and common height. Okay, so I'm going to show to you first. They gave us a ratio. They gave us a ratio. So we need to interpret the ratio first. So interpret the ratio. So this is 4 units and this is 1 unit. Because this is a parallelogram, so I'll get something like this. So the first ratio here, BEX and DCX. So if you look carefully, these two are similar triangle. These two are similar triangle. The base is 3 units. The base here is 4 units. So for part 1, these two are similar. So I'm going to use the method 1. So take the ratio. So I'm going to take the base ratio and then I square it. So the area is 9 units and 16 units. The challenging one is in the second part. So this is the one a lot of people will have some issue. So they are asking you for this green triangle and the whole parallelogram. So I'm going to target this triangle and half of the parallelogram first. So I'm going to target triangle BCX and triangle DCX first. Okay, why do I want to target these two? Okay, these two are actually common height. They will share this height. And this is 3 units. This is 4 units. So some students will be wondering, how I know that the base is 3:4? Because originally these two are similar. So the base is 3 units and 4 units. The side will also be 3 units and 4 units. And the sides happen to be the base of these two triangles. So in fact, right, so these two are similar common height triangle. So the area ratio is base ratio. And I'm going to make it into 16. So I'm going to times 4. And I got a 16 unit. I'm going to times 4. I got a 12 unit. So this part here will be a 12 units. So from here, I know that BCX is 12 units. So you can think about it this way. BCX is 12 units in area. And then DCX is 16 units in area. So this is like half the parallelogram. So half the parallelogram is 12 plus 16. So the green part is 12 units. Then DCX is 16 units. So the 16 units and 12 units. So this is the 12 units that I gotten here. From here, half the parallelogram is 28. So therefore, if you would like the ratio BCX and the parallelogram, it will be 12 is to 28 times 2, which is 12 is to 56. And if you do reduce it, you will get 3 is to 14. So this part is the common height. The first part is common height. The second part, no, the first part is similar triangle. So this part is the similar triangle. The second one is a common height. And we combine both ideas. So maybe you need to take a look. Okay, and some of you may be asking why I must make it a 16 here. Why must I make it a 16? Because this is already a 16 here. So if I multiply by 4 to make it into a 16, then I can tell my area of BCX. So I make it into the same unit so that I can tell that the area is 12 units versus 16 units for these two triangles. So this one, you may need to digest a bit before you can see the common height and the similar triangle.